Hello, everyone. Can you hear me? Okay, good. I had to switch to this headset. You guys, I've been online so much, my ear is killing me from the other headset. So I had to switch to this one. So sorry if it sounds, just let me know if it sounds bad. I can suffer through the pain if I have to. And I am exhausted. Is anyone else exhausted? Tell me. Thank you. Michaela and Karina, and I think Elena said yes too. I am literally exhausted. I feel like I could just lay in my bed right now and go to sleep. Yeah, it's true. Yeah, Vanessa, I agree with you. Too much going on. Like, I feel like, I don't know. But it's okay. It's gonna get better, I guess. Yeah, Alyssa, I need a nap too, except for I hate naps, but I could probably take one right now. I'm not sure it'd be a nap. I think it'd be like 8 hours, right? I'd be like, see you later. I'll be back tomorrow. Yeah, it's something, all right. Okay, so
Roxanne, I have a quick question.
I'm ready, Bethel.
So I signed up for that meal box
Yeah,
yesterday,
yeah.
and I was wondering, is it like drive through to the school, or do I have to like go into the front office and pick it
Nope.
up from there?
It's drive through, I think. I'll give you the link to the thing again, but I think it tells you where to drive in and then there's a phone number to call
Okay, thank
when you get
you.
there. And I think they just bring it out to your car I just had a student do it in my last class, but I didn't think to ask her.
Okay.
So I'm excited you're doing it. You're going to have to report back next week.
I chose the one that I wanted was the first one, which I think was an Alfredo. I can't remember, but I chose the tuna risotto.
Ooh,
Yeah,
nice.
so I want to see how it goes.
Yeah, I think you didn't have a lot to lose, right? Trying it.
No,
Yeah.
and I never tried tuna before, so this is gonna be an
Nice.
experience. So let's go.
Do you like fish?
I don't mind fish.
So you'll be fine. Tuna's, not, I don't think, a polarizing item.
Does it taste like I don't like salmon, so does it taste kind of like that or completely different?
Not at all. Very
Okay.
different. Very different. So, and you probably just had bad salmon, right? Because I think salmon's pretty good if it's cooked well, right? But it can be messed up.
I
Like,
mean, I ate it at a restaurant. It was like my dad's plate because he loves salmon. I took it and I was like, what did I put in my mouth?
okay, well, I'm so excited to see if you like what you get. So good. Okay, so speaking of which, there is so much going on lately. I know any of you who are not transferring after this semester, is there any of you? Okay, thank you, Jessica. I was hoping there was someone. And Bethel, is it you too, Bethel? Okay, good. So there are a couple of you. So I wanted to, because one of the things I have to share about Thunderbird Thursday is really only for people who are continuing in at MCC. So I'm going to share my screen. I'm going to do it from here. Maybe not. Maybe I've lost my mind. I mean, I'm definitely lost my mind, but that's a separate thing. Okay, here we are. All right. I'm going to share my screen. And it looks kind of weird, but this is what I wanted to show you. So, and I'll make sure this is in your slides. I just updated it afterwards. So they have scholarship workshops coming up. And some of you are like, oh, I already have scholarships, or I never get the scholarship. I promise you that I have students who say that, who they've never gotten a scholarship, and they get a scholarship. So after going to these workshops. So there's one tomorrow, there's one next Friday, and then there's one on the 13th. I think they're all the same. So you don't have to go to more than one. But if you can go to one, and the scholarship link That site was down, but it's back up. I just got an email that said it's back up. So in case you've been trying to apply for a scholarship, but it hasn't been open, it is open now. Okay. And then the other thing is the thing on the right-hand side, this, it doesn't matter if you're continuing at MCC or not. And I know it's right during our class from 11 a.m. to 1 p.m. I don't know how many of you don't have a class before this, but it's the Spring Cultural Festival. And I think it's going to be amazing. I'm going to actually request if they can record it so then we could watch it later, because it said they're going to have lots of different dances and things like that from all over the world, which I think sounds awesome. So just in case you have that, there are a gazillion things going on right now. Like everybody's trying to do things at the last minute. So there's lots of different events. Most of them are held virtually. But if you're interested in them, please go to MCC's Virtual Student Life. Remember, I've shared that with you before. So you can see if any of these events are interesting to you or it would be helpful to you. Because I'm telling you, there's so many. I couldn't even figure out what to put on the slide because there's so many of them. So, okay. And Bethel's going to give us a report about the meal kit next week. So did anyone else sign up to get one? No. Tyler, did you have something to share?
I just had a question regarding like signing up for, I saw a little note on your Thunderbird Thursday saying that classes for next semester open on the 5th.
Yeah.
Do you know, is that when the summer classes go live as well?
Yes. Everything will be live on the 5th. So
Okay.
for registration, thank you for bringing that up because I put it on that slide so I'd remember to say it and then I still forgot to say it. So
No, helps a lot. Thank you so much.
that's why I put it on the slide. So I don't forget, but yes. And that has been a long time coming too with all the craziness that happened. So I'm glad that it'll finally be up. So I'm so sorry about yesterday when I left in like 3 seconds. Yesterday might have been the longest day of my life. So here's the good news. It's over. Yesterday was yesterday. So we're good. And their midterms went fine, by the way, because it's the same or very similar midterm to what you're taking in a couple weeks. I know you're like, wait, did she just say something about midterms and it's been like 3 days? Yeah, I did. It's okay. But so I apologize for yesterday. And I know I had said we're going to present those from today. I'm not sure we're actually going to present them. We're just going to go over the answers. Okay. Because I don't want to get too far backed up. And then we're going to start with some multi-stage events. But we're going to look at the card probability from yesterday. And I'm pretty sure we only did H, and I'm not sure we even finished H. Am I right? Does that sound familiar? Okay, so I'm going to go to yesterday. I wrote my my Venn diagram, and I know Sunita was explaining her Venn diagram, and she got the same answer I got, but we set up our Venn diagrams a little bit differently. So I'll just show you how I set up my Venn diagram. And a lot of you did it differently because then we talked about how, wait a minute, let me think about it. I think it was Alyssa explained how she looked at the deck of cards and figured out how it would be 30 over 52. Do you guys remember that? Yeah, so this is how I did it. I made one of my circles face cards and the other circle spades. So, and then I drew my universal set. Remember, we always have that. So in my face cards, I had the king, queen of jack and jack of hearts, diamonds, and clubs. And then in the overlap circle, I had the king, queen, and jack of spades because that's a member of face cards and spades. And then in the spade circle, I just had ace through 10. And then outside the circle, boy, it would have been nicer if I hadn't used pink. Maybe there's a lighter pink. There we go. So in the outer part, but still in the set, which would be the deck of cards, is I had ace through 10 of hearts, diamonds, and clubs. So, and then we kind of talked about set theory notation and how we would write this. And I said I used the complement of the union, because the union would be both of these circles. And so it would be outside of both of those circles. And so it would just be that ace through 10 in those other three suits, the hearts, diamonds, and clubs. So it would be 30 out of 52, which still simplifies to 15 over 26. Now, that being said, that's probably the most complicated problem on this sheet, right? And that is not something I would ever put on a test for you. Okay. So that's just for us to be thinking about in class and things like that. The ones that would be more fair game for a test, whether it be an oral exam or an online, is A through G. Okay. So is that better for part H? Okay. And then we did A. So let's just quickly go through some of these. So the probability of a face card, I'm guessing you wrote something like this. And then how many face cards are in the deck?
12.
Very
12.
nice. Michaela put in the chat 12. And so 12 out of 52 total cards, which that's going to simplify, right? Because what are they both divisible by?
4.
There you go. So 12 divided by 4 is 3. And 52 divided by 4 is 13. So 3 out of 13. Can I confirm that was your answer for that one? Are you guys good? Okay. So any questions on that one? And I know some of you have put in the chat that you're having internet issues. Believe me, I feel your pain. A lot of us are still having password issues. Like, is anyone having trouble with Canvas logging you in or out if you change devices? Anyone having any of those issues? Like you have to change your password or anything like that? Okay, anyway, the reason I'm bringing that up, if you have any issues with technology with MCC, please use the Thunderbird Tech support link in Canvas, because that connects you directly with MCC people and they can help you. Even if they have to send you to someone else, that's a great place to start. Unfortunately, they're only open during business hours, but you know, if you have trouble, please get on that. Okay. How about a red card or a 10? This one was a little bit trickier. Anyone want to share their solution? They can even explain to us what they wrote.
I can explain that one. So
I'm ready, Karina.
so I looked at it as viewing the red card first and then viewing the 10. So for a red card, it would be 26 out of 52. And the probability of a 10 would be 4 out of 52. And then I added those. And then I noticed that there's 2 red 10s, so we'd have to subtract 2 out of 52. And then I got 28 out of 52, but that simplifies down to 7 out of 13.
And I think this was one we were talking about maybe a tiny bit yesterday. I think I was talking with Vanessa about it, that her room got different answers, right? And so we were kind of trying to make sense of it. That was a very nice explanation, Karina. Can anyone tell me what the probability notation that they wrote was?
Is it, sorry, is it, is the U symbol, is that the union one and the other one is intersection? So is it red card union 10?
Yep. And then when we calculate it, how we write out what Karina explained to us mathematically, it would be, I'm going to write it under here because I do not have enough room on this worksheet. Probability of a red plus the probability of a 10 minus the probability, and think about how you would write this, a red intersection 10. Okay. Is that nice? Do you like that? And that comes from that, remember that worksheet on healthy fish that we looked at afterwards? I'm going to go back there and see right here. Oh, it's not even on here. That's stupid. Well, now I have to add it to this one. It should be on here because they're non-mutually exclusive events. I should put it on here, but I'll write it down here. So non-mutually exclusive. I thought it was on here, but I guess not. You have to find, so the probability of A or B is you find the probability of A plus the probability of B minus the probability of A intersection B. And that's what we talked about the other day, getting rid of that double counting, right? So you don't have to do that with mutually exclusive events right here if they're mutually exclusive, because there is no overlap, right? That center part is empty. But when it's not mutually exclusive, we need to subtract that off. So sorry, that's not on that sheet. Any questions on that one? You okay with that? Now, I think a couple of them are kind of nice, right? Like part D, what's the answer to part D? And how'd you get it? Don't everybody talk at once. You should volunteer for an easy one, right? Before I call on you for a hard one.
I can go. So
Okay, McKenna.
he is only asking to find the queens, and there's just 4 of them. So it's 4 out of 52, and that can simplify to 1 out of 13.
Very nice. Thank you, McKenna. And Sunita did put it in the chat, and Bethel did too. So thank you for that. I know that sometimes it's hard to unmute because of where you are or because of the internet or whatever. So don't think I'm judging you. I just need some sort of interaction. So if you just put it in the chat, that's very helpful as well. Because I know sometimes you've heard my dogs go crazy in my house and the internet issue. So a question on E. How did you write that probability statement? What did you write? Because it says not a queen.
Would it be the complement of queen?
Yeah. And so how do we write that with notation? Does anyone know?
Put a line over the queen.
Nice. Now, one room was talking about this the other day, and they came up with like a revelation. They could have written it like this with like a tick mark right there, or sometimes you even see the tick mark over here. Yeah. So, and that tick mark means the same thing. It means not whatever that is. Now, why did the tick mark come about? Because I think this was hard to type. And so a tick mark was easier for us to use that as a complement. So I don't care which one you use, just so you know. So, and not a queen. So how did you find that answer? Not a queen.
I can go. So I kind of referenced part D and saw that we had 4 queens. So if we're trying to find the others, you take the 12 face cards that we found in part B and subtract it from the queens to get oh, sorry. Why did I say that? I meant to say the whole deck of cards. Sorry, I was looking at a different, I don't even know. But you take the whole 52 cards and then you subtract out the queens to get 48 out of 52, which I don't think I simplified. Oh wait, did I? I don't think I simplified it, but you would get 48 out of 52.
And then what would it be simplified? Help Madison out there. Oh, the Sunita already put it in the chat. 12 out of 13, which makes sense because I want you to think about this, and you see how I wrote it right here? Okay. Because to find the probability of the complement of a queen, we could do 1 minus the probability of a queen. And that was from, if it's not on here, I'm going to have a heart attack. Right here on this last one, complementary events. So the probability of the event and the probability of its complement sum to 1 if they're mutually exclusive. So if I want to find the probability of the complement, I can do 1 minus the probability of the event happening. So that was this one. So sometimes, I don't know about you, but sometimes it's nice when I make a little note and then I put like, this is, what part were we on? Part E. Part E of card activity. Right? So just I remember, so when I'm going back to study, I know where else to look. I don't know if that's helpful for you. Okay. And then a face card or a spade, we're going to say the probability of a face card or a spade. Now, be very careful. I'm only telling you this because I made a huge mistake when I taught 8th grade once. By the way, I made the mistake more than once. First, I'm going to answer Hannah's question. Hannah, question first.
Oh, I didn't know that was going to work. Logistical question on part E. Can you put the tick mark either to the left, to the right of the parentheses, or inside, or is it only to the left or inside?
I think it doesn't matter.
Like,
The tick mark's there, you're good. I could look it up and find the official word, but I'm going to accept your tick mark anywhere. Okay, so some of you can see it coming already, what I did. Yeah, McKenna's already chuckling at what I did. Let me tell you, this problem used to read a face card or a club. And do you notice I abbreviate face card with an F? And I abbreviate club with a C. And then there's a symbol in the middle that looks a lot like a U. So I was teaching 8th grade and I wrote on the board and I said out loud, right? What's the probability you get a face card or a club? And I wrote on the board, P parentheses, F, the union symbol, and a C. And I closed my parentheses. Literally 8th grade, you are never living that down. I might as well have just ended the, like just dropped my pencil and walked out of the class because it was a nightmare. It was a nightmare. So, and here's the best part. The next year, because I only taught that once, and then the next year I pull out my worksheet, it still says it because I forgot to change it. But I didn't write it on the board that time. Thank goodness. I didn't abbreviate. I wrote out everything. So I only really made the mistake once. But of course, 8th graders don't let it die, right? They say, oh, are you just saying what's the probability you get? And I was like, oh, stop, time out. We changed the whole lesson. It was a nightmare. So helpful hints to you, please pay attention to and I had it written on my paper just like that. It never dawned on me, right? That's what was going to happen. So just so you know, be very careful because you will not live it down. You will not live it down. Like the next, even on the test, I had students writing stuff in there. Yeah, it was lovely. So don't do it. What a nightmare. Okay, so a face card or a spade in this case, a face card or a spade. What did you get for your answer on that one? And how did you get it? Did you do it similar to the red 10? Yeah, because that's how I did it. I said, okay, what's the probability it's a face card plus the probability of a spade minus the probability of a face card and a spade, because those things can happen at the same time, right? Those are not mutually exclusive events. So I got 12 out of 32, sorry, 52 plus 13 out of 52 minus 3 out of 52, which simplified to 22 out of 52, which was 11 out of 26. Is that how many of you got that? 11 out of 26. Nice. Yeah, and then G is a face card and a spade. So this time we're not going to add them together. We're just counting these three right, that we had to subtract off. So it's just 3 out of 52. So those aren't too bad with the exception of part H. Am I correct? Part H was the problem child, but that's okay. All right, any questions on A through H? Okay, so my question on my slide now is, look at number 2 and the directions where it says 2 cards are drawn from a deck with replacement. This means one person chooses a card, looks at it and returns it, and then another person chooses a card, looks at it and returns it. And it says find the following probabilities, and there's A through E. So how are these problems different than the problems we just finished? Any ideas how these problems are different?
The other problem, the first problems were dependent. Does that have to do with, never mind.
That's okay. You're just getting a little ahead of yourself, I think, but that's okay. So these problems, the original problems, just one thing was happening, right? We were only getting one card, right? On A through H, we were only picking one card and finding the probability of that one card. In number 2, are we picking one card? No, we're picking 2 cards. Yeah. So that's how this changes. So that's why this section is called multi-stage events. So more than one thing is happening. And we could do it with anything, not just cards. We could do it with a coin, right? We toss a coin and then we toss the coin again, right? We could do it with rolling a dice. We could do it with anything we could do it with. So sometimes we have multiple stages. So if we flip a coin, we record it, we flip it again. If we pick a card from a deck, look at it, put it back in the deck and pull another card. Or think carefully about this one. We pick a card from the deck, we look at it, and we don't put it back in the deck and we pull another card. So these scenarios are multi-stage events that have to be calculated differently depending on whether they're dependent or independent or mutually exclusive or not. So when you have multi-stage events, you have to look more carefully at what's happening in there to help you with the probability. Okay. So independent versus dependent. So is it with replacement or is it without replacement? So sometimes it doesn't even matter if it's with replacement or without replacement. You just have to think it through. Like, for example, independent would mean if you're tossing a coin, doesn't matter what I tossed 5 seconds ago to what I'm going to toss right now. They're separate events. Same with rolling a dice, right? They're independent of each other. One does not affect the outcome of the other. Does that make sense? And notice that I put a little note there that the sample space remains the same. So if you think about with tossing a coin, when I toss the coin once, I have 2 outcomes, heads or tails. Well, when I go to toss the coin again, I still have those same outcomes, heads or tails. So my sample space hasn't changed. Same with if I have cards and I put it back, right? Because I still have 52 cards in the deck if I put it back. But when it says something strange, like without replacement, then your sample space is going to change because now that card has been removed. So for example, what's the probability you pull a king on the first draw and a 10 on the second one? Well, the probability of a king, we already know, is 4 out of 52 or 1 out of 13 because we already did that. But then once that king is gone, I only have 51 cards in the deck. So my sample space has changed from 52 down to 51. So that's a dependent event because what happened before affects my new event. Okay. Has anyone played the game Guess Who? Yeah, it's one of my favorite kids games. Yeah. So would anyone not know how to play Guess Who? You're like, wait, what are we talking about? Okay, so it's a board game. Karina, you got to get out more. You don't play cards. You don't play. Are you not a game player? Come on, man. Someday I'm going to take you on a tour down of my game cabinet. You will die when you see it. It's actually overflowing. I have games in every room now. But so Guess Who is a kid's game with a little board and all the people flip up on it. I don't even know how many people are on it. But there's females and males, and there's people with hats and not hats and glasses and no glasses and facial hair and not facial hair and whatever. And you pick a person, and that's who your person is. And the other person picks a person, and your board's like, you can't see each other's boards. And you ask yes or no questions of the other person, and you're trying to guess who they have. That's the name, Guess Who. So you ask questions like, is your person female? And they can say, yes. And if the person's female, then you're going to put down all the people that are males, right? Because that's not an option. So that's an example of without replacement. Now I don't have to guess them anymore. So they're not part of my sample space anymore. Yeah. So funny story about Guess Who. My nieces were playing. Have I told you this story? My nieces were playing when they were like 4 and 6 in the car. We had travel Guess Who because we're insane. And so we're playing in the car, travel Guess Who. And the 4-year-old asks the 6-year-old, is your person a follower of Jesus? And the 6-year-old's like, Mom, Jesse's cheating. You know, and Rhonda's like, what are you talking about? Jesse's cheating. Jesse's like, that is a valid question, right? Like, is your person a follower of Jesus? And my sister's like, what is happening right now? Like trying to figure it out. And the older daughter is like, this is not a valid question, blah, blah, blah. And so finally, Jessie explained it. Well, she's like, yeah, you know, is it Matthew, Mark, Luke, John? And she's like naming all of the disciples or followers of Jesus. And Kristen was so mad because there's not very many, right, in the Guess Who board. And hers was a follower of Jesus. So she knew as soon as she said yes, Jessie was going to win. The 4-year-old was going to win. Funniest thing I've ever heard of. I don't know how they thought of that. How did the 4-year-old think of that question? But hilarious. I wish we had it on video because that was classic. So it'll be interesting if you guys ever have that question come up in class. I think it's fascinating. You get a lot of insight into kids' backgrounds when they ask those questions. My son came home in 5th grade and said, did you know that Sadiq and Ahmed are Muslim? And I was like, shocker. Yeah, I did know they were Muslim. And then I was like, how did this come up? And they're like, well, we were talking about Jesus on the playground. And I was like, well, who'd have thought? And they were comparing Muhammad to Jesus on the playground. I'm like, well, good for you. Good luck. Let me know how it goes. So fascinating conversations on the playground. I was like, was that before or after you were going down the slide? I don't know. Weird. Okay. So Guess Who is a good probability game. Yeah. Fun one. Okay. So independent versus dependent multi-stage events. Events A and B are independent if the probability of event B occurring is the same whether or not event A occurs. So like we talked about, when you toss a coin, doesn't matter. When you do cards, doesn't matter. So here's my example here. The probability that 2 cards drawn at random from a deck will both be aces. If the first card drawn is an ace, then the probability that the second card is also an ace would be lower, right? Because there's only 3 aces left in the deck because 1 is gone. You already picked it. Does that make sense? Okay, so drawing out your sample space and thinking of these really help. Now, we're going to do an activity called the pom-pom activity. This is one of my favorite activities to do in class because we use actual pom-poms. I didn't bring my pom-poms home, but we'll just use my colored chips. Do you guys know what pom-poms are? Those little fluffy balls that you can buy at the dollar store. Another very inexpensive manipulative, by the way, because sometimes they only come in 2 colors. Sometimes they come in all kinds of multicolors, right? So, but I'll use these chips instead, just color chip. Remember Insta chips? Yeah, so you can use yours for anything you want. And so, yeah, do you guys have this worksheet? Let me give it to you in case you need it. You really don't need it unless you just need to read the paragraph because the rest of the page is blank, right? So I'll make sure you have it. Let me get it here. Okay, the other thing I can't show you because we're not in class is most whiteboards have magnets, right? Or are magnetized, so magnets stick to them. Have you ever seen a teacher who uses magnets a lot with their whiteboard? It's very convenient. So, but I am a cheapskate. If you learned nothing from me, I'm a cheapskate, so I don't buy magnets. So when I have my pom-poms, picture this as a pom-pom, not this. So this would be just a pom-pom of one color. And I take those magnets. You ever go to your dentist and they give you a magnet? Or they send you a magnet calendar from a realtor or a pizza place. Do you know what I'm talking about? Those magnets that you put on your fridge and then you're like, why is that on my fridge? It's so hideous. I hate it. Yeah. So I take those and I cut them up and I use a glue gun and put them on the back of my item and then they stick to my board. And I never bought a magnet again. So there you go. And sometimes I got really greedy and I was at the pizza place and I was like, oh, do you have any refrigerator magnets? And they're like, yeah. And I'm like, can I take a few? And they're like, oh, sure. And then I felt a little guilty for about 5 minutes, but it's okay. I feel like then I told people where I got them from. Like I grade in purple pen and I don't like to buy purple pens if I have to spend my own money. And Planet Fitness just happens to use purple pens. Did you ever notice that? So I was in Planet Fitness once and I'm like, oh, I love your purple pens. I'm a teacher and I grade in purple all the time. And they're like, here. And they gave me like 25 pens. And I'm like, you're awesome. Bye-bye. So, but I don't belong to Planet Fitness anymore because of COVID. I'm just saying. I did love Planet Fitness though. So see, I will still plug them and their purple pens. So anyway, you can use these and put them on your board. And it's a great manipulative so students can move them around, right, when they're doing them. So let's get back to this. A box contains 3 white balls and 4 colored balls. The reason I specifically said 4 colored balls is because my pom-poms were all crazy colors, right? And then I didn't have to like pull out pink ones or red ones if I would have said red. So it was just white or not white, which was nice because in my things, and I could have made it red and not red, but that was just the way I did it. Suppose that a ball is drawn at random from a box, the colors recorded, and then it's put back in the box, okay? Then a second ball is drawn and recorded. Now it says draw a tree diagram. Now we did tree diagrams in 256, but they were really for like prime factorization, right? Or something like that. And they were usually up and down. In probability, oftentimes we do tree diagrams left to right. So it might be a little bit different for you. So, and then this second question over here, this one is with replacement. Do you notice this one is without replacement? So this one is going to be independent. So our sample space is not going to change. This one is going to be dependent because we're not going to put the first ball back in the box. Okay. So if we start, we're going to say our first pick. Okay. And our first pick, how many options do we have of what we're pulling out of the box? If we have 3 white ones and 4 colored, what do we have as options? How many of you agree that we would have white or colored? Yeah, we really only have 2 outcomes here. They're either white or they're colored. There's 7 balls in the box. But if I was drawing my sample space or writing my sample space, remember, we don't have to put repeated items in there, right? We just use that to compute our probability. So really there's just white balls or colored balls. Okay, so that's what my W and C is. I could have drawn them, and so when I do it on the board, I literally just put these on the board, right? White, colored. Yeah, it's very convenient. So Any questions on what I did so far? Because I'm going to set you to work on the next one by yourselves, which is a little bit harder. Okay, so what's the probability that I get a white one on this problem right here?
It's 50-50.
It's 50-50. There's the same number of white as colored balls in this box.
Wait, would it be 3 out of 7? Oh, wait. Oh, are we counting the 3 white balls or just only one of them? Like, is it 3 out of 7?
Oh, it is 3 out of 7. So because there are 3 white out of a total of 7, don't you agree? Think about your cards, right? If we were finding the probability of a queen, there were 4 queens out of 52. So the same thing here. The probability of a white is 3 out of 7. Nice, better? Okay, so then what's the probability of a colored ball?
4 out of 7.
There you go, 4 out of 7. Now, it's not a coincidence that 3/7 plus 4/7 is 1 whole. Do you notice that? So those 2 branches right there on that tree sum to 1, because 1 is the total probability, right? Probabilities on a scale from 0 to 1. Everybody okay with that? This is kind of a nice double check. Now, I'm going to draw another branch because I'm going to say this is my second pick. Now remember, in these directions, it says I pull it out of the box, I look at it, I write it down, I put it back in the box. Okay. So when I go to do my second pick, how many balls are in the box?
Still 7.
Yeah, there's still 7. I didn't change that. So I still, when I follow along this branch, I'm saying I took a white one out. I looked at it, I wrote it down, and then I put it back in. So then when I draw my second ball, I still have 2 choices. I could get white or colored, right? Does that make sense? Because I put it back. Now, what do you think my probabilities will be on these 2 branches?
The same. The same?
Yeah, they are the same. You're like, something's wrong, I don't like that. Yeah, they are the same because I didn't do anything to the box, right? So just so you're following along with me, if I continue this branch, what that means happened is that I got white and a white together. Does that make sense? Because I pulled a white one first and then I pulled a white one next. Whereas if I do this second one, I got a white one first and then a colored one. So it's a different outcome. You okay? Okay. So, but I could have not pulled a white one the first time. I could have pulled a colored one the first time, right? I could have. Maybe I should use a different color. Oops, that was stupid. All right, so I could have pulled a colored marble the first time or a colored ball the first time, but I still have 2 outcomes, white or colored. Do you agree? I just happen to get a colored one instead of a white one. So what do you think my probabilities are on these 2 branches?
Same.
Very nice. 3/7, 4/7. You're like, this is a stupid game. Seems too easy. Gets harder on the next part. Okay. So, and again, if I follow this branch, this outcome would be a colored ball first and then a white ball. And if I follow this branch, I would get a colored ball first and then a colored ball. Does that make sense? So I'm just saying, and some of you are like, I could have written down WW, WC, CW, and CC without drawing that big tree diagram. That's true, you could have. Some people are less visual, right? That's totally fine. Okay. I happen to love tree diagrams. Okay, so, and then the last thing you want to do is notice that these 2 branches still sum to 1. These branches still sum to 1, right? So now the trick here, or the idea here, is how do I find the probability that I get a white ball and then a white ball? Well, if I follow along this branch, to get the first white one, I got 3/7, or I have a 3/7 chance. Then when I keep going on the branch to get the second white one, I'm going to actually multiply those probabilities, because that's one way you can do it. And if you think about it, it would make sense, because there's no way I can add them, right? If I added 3/7 and 3/7, I would get 6/7. That's really close to one whole. And that would say it's really likely that I get a white and a white, but I don't think that's true, right? So, but if we multiply them, watch what happens. We get 9 out of 49. Do you agree? Okay. And then if you do it with the next one, you get 3/7 times 4/7, which would give you 12 out of 49. And then the next one, you would do 4/7 times 3/7, which would give you 12 out of 49. And then the last one, 4/7 times 4/7, which is 16 out of 49. And those are all our possible outcomes. Now, remember, we were only picking 2, right? We were only picking 2. We're not going to keep going. Like we had 7 balls in the box, so we could do it again and again and again. But pay attention when it just says we're only picking 2 balls, right? That's it. Okay. Now, do you notice anything about all of these numbers?
They add a 49, right? So it gets one whole.
Aha, very nice, Madison. So if we take 9 over 49 plus 12 over 49 plus 12 over 49 plus 16 over 49, we get 49 over 49, which is one whole, which should make sense because we've exhausted all the probabilities. Yeah, it's a nice way to know if you did it right. Okay, so if it sums to 1. Okay, I love your reactions, Karina. Keep them coming. Love them. Okay, now we should probably answer the question that it actually asked. Find the probability that the 2 balls are different colors. Okay, so find the probability that the 2 balls are different colors. So out of these 4 outcomes right here, which ones meet that criteria of 2 balls that are different colors? "12 out of 49, which outcome are you mentioning, Sunita? Ah, so Tyler put that there's 2 different outcomes that each have 2 different colors, right? So these 2 in the middle, this one, WC and CW, both have different colored balls, right? So to find the probability that they're different colors, what do you think I need to do with those separate outcomes? Any idea?
I was just going to add them.
Very nice. Excellent. Just add them together. Why wouldn't you multiply them? Any ideas?
Oh, because probability, doesn't it have to stay within 0 to 1?
It does. Yep, it does have to be within 0 and 1. And it just doesn't really make sense in our brains, right, to multiply those. Because if we know that these are our total outcomes, then if these are separate outcomes, we should just be able to add them together. Think about your cards again. What's the probability you get a 2 or a 5 in a deck of cards? Well, there's 4 2s and there's 4 5s. So you would say 4 out of 52 plus 4 out of 52, which would give you 8 out of 52. You wouldn't multiply them. So you can always relate it back to something else that makes sense to you. Okay, so the probability that they're different we get is 24 out of 49. Questions on that? That was a lot.
How would you write the correct notation for that? Find the probability that the two balls are different colors.
I just really wrote it out in words, and then I typically wrote it like this. So then I would write the outcomes. I would say, okay, the probability that it's white colored plus the probability that it's colored white equals the probability that they're two different colors.
Okay, thanks.
All right, so that was the easy one. Jessica, your face just said it all. I don't know if you were just looking at your screen, but that timing was impeccable right there. Thanks, Alyssa. I appreciate that. So the second part isn't that much worse, but you do have to do some more thinking. So I'll get you started on this second one, and then I'm going to put you in breakout rooms because I want you guys to really think and figure it out. So the first branch, notice it says, okay, this is using the same stuff, right? So it's the same boxes from part A, okay? The only difference now is when we take the ball out, we're not gonna put it back in the box. So that's what makes this a dependent event. So the nice thing is your first draw, you're still gonna have white or colored, and you're still gonna have 3 7s and 4 7s because we have the same box. Does that make sense to everyone? Okay, it's the second draw where it gets a little worse. So I'll just get you started and we'll think it through. So if I pulled a white ball, so if I follow this branch along, if I pulled a white ball on the first draw, what are my possible outcomes on the second draw? Can I still get either a white ball or a colored ball? I still can, white or colored. But something's changed, right? How many balls are in the box now?
6, right?
There's only 6 balls in the box. So each one of these denominators is going to be 6. Does that make sense? Okay, now what I want you to think about is, okay, this branch says I took out a white ball. So what's the probability I'm going to get a white ball on my second draw? Karina put it in the chat, 2 out of 6. I totally agree. And Michaela put 1/3. She just simplified it. I left it as 6 because it helps my brain understand it. If you simplify, it's totally fine. But if you're struggling, don't worry about simplifying until the very, very end, because it might help your brain to understand I went from 7 balls to 6 balls instead of I went from 7 to 3, right? That might hurt your brain a little bit. Okay, so what number must be the numerator of my other fraction? Sunita, you're right on it. 4/6. Do you notice that 2/6 plus 4/6 is still 1 whole? Do you notice that? Yeah, so that's a nice double check for you. Okay, now what I'm going to ask you to do in your breakout rooms, I want you to finish your tree diagram. Yes? And I want you to list all your outcomes, just like I did over here, right? And I want you to answer this question. Find the probability that the 2 balls are different colors. Okay? Everybody know what your task is. Excellent. If you finish and you're waiting around for me, right? Then what I would like you to do is go back to your card probability and try number 2 and see how you do, because now you have all the math tools to do it. You don't have to draw tree diagrams with cards, okay? But the idea is still there, multiplying these 2 together. Okay. Any questions before I put you in breakout rooms? Okay, I'm going to open them up. Please, please, please call me in to help you if you need it. Okay. Okay. And if you get kicked out, just stay in this main room and work, and I'll come back and check on you. Okay. Because I know some people get kicked out and back in and out and in.
I have a quick question. You're muted.
Yes, go ahead. Sorry.
So did you say that next week we have a group like activity or project to work on, or assignment?
Yes.
Will we be assigned a certain group?
Good question. I'm not sure what that assignment says. I'll have to look at what I said before, but yes. I mean, you'll definitely be in a group.
Yeah.
You know, who it will be with, I'm not sure. I have to look at my assignment description, but it'll be up by tomorrow.
Okay.
So you'll have it by tomorrow.
Okay, thank you.
Yep. Okay, welcome back. Sorry. I really need this class to be about 5 hours long. I'm just saying, maybe just 3. Maybe I could do 3. You're like, yeah, if you would stop telling us stories, maybe we'd get through stuff. Sorry about that. All right. So do your branches look like my branches? Yeah. Any questions on where I got those numbers? All right. And so do you see how I drew this little picture right here and this little picture right here? Sometimes that helps people, right? To go back to the original of what's happening. So you can always draw those little pictures off to the side if you want. So now we would again do these 2 middle ones would be our ones that are different colored. And so we would get 24 out of 42, right? Instead of 24 out of 49. So which one's bigger, 24 out of 49 or 24 out of 42?
24 out of 42.
Yeah, and does that make sense to you that your probability would be higher if you remove it from the box? Yeah, because now you only have 6 to pull from, right? So good job. Okay, last thing, because I know it's going to be time to go. This problem right here is kind of hard, kind of tricky. If you want, you could do it for extra credit and send it to me. Okay, just shoot me an email. Okay, and then the card problems, try those for homework and we'll just compare them on Monday. It's not an assignment, but it's a good way to kind of see if you understand the card probability. Okay. All right, so let's go to your assignments. There's all your assignments for the week. A lot of you have done a lot of them already, and you do have an exit ticket. And I hope it's a nice one, self-grading. I can't click on anything right now. Story of my life. Okay, and then I should open next week's module. I'm hoping by tomorrow afternoon. So I know some of you like to work ahead, right? Because the week gets really bogged down. So if you don't see the module open by, say, Saturday morning, send me a message because I might have forgot to push a button. I'm going to try to get it published early. But yeah, I can't believe the first week is already over. Hey, but we learned a lot already. Crazy. You guys are awesome. I appreciate all your effort in class. I know that this class can be overwhelming. So don't think that I ever take take for granted how much you guys work, right? Like I know you guys are working a lot. I tried to lighten the load a little bit this week. Did you notice? It's a little bit better. I hope nobody's crying yet. Okay, good. Alyssa gave me a thumbs up. So good. All right. And I will see you Monday. If you have questions, stick around. I don't have to run onto a midterm, so I'm good to go. And I'm happy to help you guys any way I can. Otherwise, happy Easter, right? Yay. I love Easter. Yeah. We have a Zoom on Easter. We're making bunny cakes. It's a bunny cake Easter. Because my birthday is always by Easter. And so I always had a bunny cake for my birthday. So the Zoom is for me. Yeah, it's true. I was born the day before my mom turned 30. I'm her baby. So her birthday and my birthday, we always had bunny cakes. And my son was born on the day after my birthday too. So on my mom's birthday. I know it's crazy. April birthday time. Sorry, I should let you do math.
Roxanne, I have a really quick question.
I'm ready.
So my group was looking at the card problems, question number 2, and we were just wondering, so for the pom-poms, how we had to solve, multiply across every single, outcome, or I don't know, sorry, I don't know vocab quite yet, but how we had to multiply every single numbers together. So if we're just given if we're just given the question like, oh, if we're finding the probability of this, do we have to, I know this is kind of being lazy maybe, but do you have to find every single one, or can you just find the multiply the two, like the ace and the black card probabilities together?
Yeah,
Like,
that's all you have to do. No tree diagram necessary. So if you look, can you see my screen still?
Yeah.
Okay, so the probability of an ace and then a black, we're going to take the probability of an ace times the probability of a black card. Okay, I should not abbreviate. I should have written out ace. Sorry. So what's the probability of an ace, Madison?
I think we got 4 out of 52.
Okay, which simplifies to 1 over 13.
Yeah.
Okay, and the probability of a black card?
That's 13 out of 52. Oh, sorry, 26 out of 52. It's half a deck.
26 out of 52,
Which
so
is
that's
one half, right?
Yep, and so my answer would be 1 out of 26.
Oh, so you don't even really have to do the tree diagram unless
No, not for cards. It's really
for
helpful
cards?
when you're just doing balls in a box or
Oh.
flipping a coin or something like that. Yeah.
So the tree diagram is used for like something. Oh, okay. So like color. Well, not colors, but like where you only have like.
Yeah, like
couple
more of an experiment, like where you're pulling something out of a box. That's probably the most common thing that you see.
Mm-hmm.
Yeah.
Yeah,
And
I was kind of scared. I was like, oh, are we gonna have to do the
No.
tree diagram every single time for the card problem too? But it's because there's a lot of, there's 52 cards, and that's a lot of,
Right.
writing
Now you
out every single. You could, but like,
Well, and you could make it easier. You could say, okay, so the first card, right? So the probability of our first card, let's do our first card here. So that's either going to be an ace or not an ace,
mm-hmm.
right? So that would be
That's what
4
we
out
were
of
doing,
52
yeah.
or 48 out of 52. And then for the second card, I can't write right there for some reason. The second card,
You want colors, right?
I
Red.
want it to either be black or not black. We could call it red since we know it's red, right?
Mm-hmm.
Now, I don't even care about this part
Yeah.
because I don't want it to be not an ace. I want it to be an ace.
Nice and black.
So,
Okay.
yeah, so I only want this branch right here. So, and I could write, okay, the black is 1/2 red is 1/2. So, and I could simplify that. So then I only want this. So, because I want ace and black. So I only want 1/13 times 1/2.
Okay. That I know
So-
that makes it a lot easier doing the I mean, it just now I like the tree diagram because it helps me, see that it's not just the only option. Like you can see that it,
Right.
because at first I was like, well, that you can't, it's not like they're taken out of the pile and you can only get an ace or a black card. Like it's still a possibility. So it helps me, visually see, but I still
Right.
like how, I mean, once I get comfortable with the tree, then I can go back to,
Right. And you'll see
Simple
some
C plus-
applications. We'll do more tree diagrams on Monday. And so you'll
Okay.
see them in a different way, see other applications of when would I need a tree diagram.
Mm-hmm. So we're just gonna probably have to know for test. I mean, like the the midterm, like different, like whether or not to use a tree diagram, or if we can just use the formula.
Right.
Okay.
And online, so on the online midterm, I do have some tree diagrams. Like I have a picture of one for you and I say, is this the right tree diagram or not the right tree diagram? And then use that tree diagram for the next problem. And on the oral one, I don't have one that specifically says use a tree diagram for this.
Okay.
So
Sounds good. Thank you so much for your help. And then one last quick question. What was that worksheet again that you said we could do for extra credit?
it's the very bottom of this pom-pom. If you just scroll down, it's the last question. Do you see it's, let me find it. Hold on. I swear it was right here. Why is it not there? What the heck?
Well, this is the card one, right?
It's on
Would
the-
it be on
Oh.
a different one?
Yeah, maybe I should be on the right handout. It's this one, number
Uh-huh.
2, right here, which should just be at the bottom of your page.
And you said it was difficult, right? Like it's
I
more
don't think
challenging
it's-
than the pom-pom.
I don't think it's terrible, but it's a thinker, right? It's more difficult than the ones we just did.
Yeah.
But it's,
Are we
I don't
able
think
to
it's,
get like a starting, since we're staying, are we able to get like a starting point?
the key to it is reading carefully, because it says, here's what your boxes look like to start. And then the key is it says a ball is picked out of box 1 and it's put in box 2.
Oh, so
So
we're
you have
adding to box 2
Yeah,
then.
and you have to be careful because you could pick a white ball and put it in box 2, or you could pick a colored ball and put it in box 2.
So you just
those
have to
are-
watch the numerator, or I mean, you have to watch the numerator and the denominator, right? In box 2.
You got it.
Okay.
So I would just start your tree diagram like normal and call the first 2 branches box 1, or your first
Yeah.
pick from box 1. And then your next one is going to be your pick from box 2, right?
Mm-hmm.
You
I'm
can
just
do
trying
it.
to think. You just okay.
And a nice way to do it would be to use items, like if you could even use pieces of paper,
Mm-hmm.
literally, and do it so you can see. Like how many-
Visually.
Exactly. Or I mean, you could draw it on a whiteboard too,
Oh yeah.
but sometimes moving the objects is kind of nice, right?
Yeah, because that's what remember in the pom-poms, I was like, it's not making sense. And I was like, oh wait, well, you didn't replace it. So obviously there's not going to be like an additional,
And
white or colored ball. Remember I made the connection because I was visually thinking about it and I was like, oh duh, that doesn't make sense.
and that's why it's nice when we're in class, because we can actually move them, and we can do it on a whiteboard together, and then you're like, oh, I can see it.
I know these poor kids, I mean, some of them learning online, it's hard without that virtual, I mean, hands-on learning. I know those poor kids having to look at, 2D diagram rather than they can actually, hands-on, because I'm a hands-on learner. I don't know if I could have done online school when I was.
Yeah, poor kids, nothing. Poor teachers. I'm just kidding.
Yeah, and the poor teachers. That's hard teaching a whole. Oh yeah, I give credit to both because man, this is
It's so
hard learning it. So I can imagine teaching it.
It's so funny because people are like, I was a teacher for 25 years, and now COVID, now I'm a streamer. It's like,
Literally,
yeah.
like a YouTube streamer
Tyler,
with
do you
like
have a
little
question?
boxes to teach.
Just real quick, sorry, I was trying to rack my brain on the card. So question number 2 on the cards for
Yes.
E, I just want to see if I'm on the right track, and it can just be quick yes and no because I
Okay,
think I
on
am.
E, nice. Would you,
I got 1/2.
it's not 1/2.
Now, okay.
But here, I want you to think about this. The first card is an ace or the second card is black. So remember, ors are inclusive. It could be both.
Okay.
So we could have an ace, right, as our first card, and the second card could not be black, right? That's one option. Or I could have the first card's not an ace, but the second card is black. And then what's my third outcome? That's usually the one people forget.
Oh my God, I didn't even think about that. It's okay. So your first card could be ace and black. It could be, or
Yeah.
your first card is ace and any, or your third option is any card and a black card on it.
There you go. So
Then
it's
it'd be
three, there's
14.
3 outcomes. Yeah. So what'd you say, 14 out of what?
26.
There you go. Yay!
Dang it. I was on the right track, but I missed it by that much.
Okay, how'd you do on part D then? Because part D is kind of similar.
I didn't. I kind of, we looked at it. I think we were like on the right path, but then we kind of got lost. And I was like, you know what? I'm just going to wait and try and solve it once I figure out this one. Cause I think they were similar. I just
Yeah.
wanted to make sure my brain was on the right path with it. Cause
I-
at first we got 1/13th, but I'm like, something doesn't seem right about
Yeah.
that.
Can you see my screen still?
Yes.
Okay, so this is a slide. Do you see how it says this one is at most? So, and yours is at least, I think, right?
Yes.
Does your worksheet say at least? So
Yep.
this is an at most, and there's 3 scenarios, right? So at most, you could have neither card be an ace, or you could have one be an ace, one not be an ace, right? The first one be an ace, the second one not be an ace, or reverse that. So when you're doing at least, you would still have these scenarios, right? Hold on, sorry. You would still have this and this, ace and not an ace, and not an ace and an ace, but this part would change. What would yours be? If it says at least one card is an ace. It's a minimum requirement only. There's no maximum requirement. So yeah, it could be ace. I don't know why that's not right. Ace and ace. So you have to take all 3 of those outcomes.
Okay.
Does that make sense?
Yep. That makes a lot more sense. And that's where I was kind of like, I was looking, I'm like, oh my God, I think I'm on the right track. And I can't believe I missed that third option because I didn't.
Everybody misses it, so no worries.
Okay, perfect. Then that answers that question. I'll be able to solve it now that I know
Yay.
I'm on the right track.
Yeah, and then that will help you with that extra credit one of least and most.
Okay.
Okay.
Okay,
Thank
so that'll
you.
help you with that. Yep, see you later.
See you later.